Users of Oz Optics laser-to-fiber couplers should consider our product line of polarization alignment kits and tools. These tools allow you to align and lock the couplers to achieve better coupling efficiency, more secure performance over time, and better polarization extension performance. The basic alignment kit consists of a multimode patch cord with a connector matching your coupler, along with video instructions explaining how to align your optics. These video instructions are available either on a DVD or on a USB drive, and these instructions cover our complete product line of laser-to-fiber coupler systems. In addition, we offer a polarization alignment tool which is used with our receptacle style couplers to align the receptacle on the coupler with the polarization axis of the laser. We also offer a Torx screwdriver, and this screwdriver is used when locking the locking screws on the coupler to ensure that they're tightened enough to prevent the coupling from moving, while at the same time not too tight to damage the tilt screws. In this video we will show how to use both the polarization alignment tool and the Torx screwdriver to achieve optimum performance with one of our receptacle style polarization maintaining laser-to-fiber couplers. All polarization maintaining patch cords have connectors with keys, small protrusions that are on them that made up with a matching keyway on the female receptacle of a coupler. In polarization maintaining fibers, the stress rods of the fiber are aligned with that key on the connector. So if the keyway on the coupler is aligned with the polarization axis of the fiber, then one only has to simply plug in the fiber and it will be automatically aligned with the polarization axis of the laser. To achieve this, we use a polarization alignment tool. This is a simple device which has a small polarizer inside and allows the light to pass through so you can see the output on a screen or using a power meter. We'll demonstrate the use of this in this next segment. So let's demonstrate how to use our polarization alignment tool to optimize the orientation of our polarization maintaining laser-to-fiber coupler to our laser. The laser-to-fiber coupler has a male threaded adapter on it, whereas our laser has a female threaded adapter on it. Both the male and the female threaded adapters are available from Oz Optics. The female threaded adapter has two set screws located 90 degrees apart, which are going to use to fix the orientation of the coupler once we have it optimized. To begin with, we'll simply thread the coupler onto the laser. And we're going to thread it all the way to the very bottom, because we want to have the maximum thread engagement of our laser-to-fiber coupler so we have maximum security. Once we reach the bottom, we now attach our polarization alignment tool, making sure that the key on the alignment tool goes into the keyway of our female receptacle. Now inside the alignment tool is a polarizer, and this polarizer is aligned 90 degrees to the key on the connector. So when the key on the connector is aligned with the polarization axis of the laser, the polarizer will block the light and prevent it from passing through. So what we're going to do is rotate our coupler until we block as much light as possible on our screen. We're using the screen so you can see it visually, but for more accurate results we recommend that you use a power meter. So as we just rotate the coupler to loosen it, we'll see that the light goes dim and dimmer to the point where it blocks out. If I keep going, you see the light gets brighter again. So I'll rotate it back till I reach that point where the power is minimum. And once I reach it to my satisfaction, I simply tighten the set screws on both sides. You now remove the polarization alignment tool. And the coupler is now attached in the optimum orientation for the polarization maintaining fiber. You now simply proceed aligning the laser to fiber coupler to your fiber as per our standard video instructions. For the sake of this video, we're going to align that and then come back and show you the results. Okay, this is about the optimum power out through the fiber. Okay, so we're going to use our Oz Optics polarization extinction ratio meter in order to test the results here. So we're going to just plug in the fiber. And make sure that the key is engaged with the keyway. And we'll start checking what our performance is like. And as you can see, we're getting numbers being read out in the high 20s, low 30s. Now, with polarization maintaining fibers, it's always important to stress the fiber and observe the results. So I'm going to put my hand over the fiber, and you can see as I do that, the power drops slightly. We get numbers as low as about 24 dB here from our reading and before it jumps up. But basically a number better than 20 dB shows that our alignment is good. If you need to get better performance, you may spend some time perhaps fine adjusting the alignment if necessary. But in general, using the polarization alignment tool, getting results in the 20 to 25 dB range is quite straightforward with a minimum of fuss. Now let's demonstrate how we use the Torx screwdriver to optimize the tension on our locking screws. We've already aligned this coupler to give maximum light out from our fiber. To start, we're going to bring in our locking screws using our regular screwdriver until they just touch. You can do this with the Torx screwdriver as well, but for now we'll use the regular screwdriver. And we're bringing them in until they just touch. The Torx screwdriver has a special ratcheting mechanism on it. When a screw is tightened to a specific torque, the handle will ratchet, limiting the maximum torque that you can apply on the screw. The level is being set here at Oz Optics, ensuring that when you tighten the locking screws with the screwdriver, the tension is set to a point where we know that the coupler is firmly secured, but at the same time you are not tightening the screws so tight that they can get damaged. So now we'll use the Torx screwdriver to tighten each screw. So starting with the top one, we'll adjust it. As we do this, the power from our fiber is dropping. That's fine. We're going to recover that power as we finish our function here. We'll go to the second screw, tighten it, and we go to the third screw and tighten it. And again, you're looking for that ratcheting point. And as you can see, once I hit it on the third screw, our power comes back. Now for the final adjustment, to try to get everything to the absolute optimum power, you would use a power meter and proceed to tweak each one of your screws, one at a time, just the locking screws. And again, at this point you're just doing a very fine tweak just to get that maximum power reading. Once you're done, your power will be at a maximum level, and if you use the Torx screwdriver in the coupler and turn it, the output power from the coupler will not change. At this point, The locking screws are fully locked and your coupler is ready to use.